Another way to write a quadratic instead of in standard form is in vertex form. So vertex form is f of x equals a times x minus h squared plus k, where a is not equal to 0. So this form is actually really helpful because you can find the vertex just by looking at the equation. So instead of having standard form and having to do x equals negative b over 2a, finding x, and then plugging it in to find y, this is already given to us. So the vertex is h comma k. So it's the opposite of what's inside the parentheses. Since it's a minus h, we always just take the opposite for the x value, and then the k value is our y, and that's exactly whatever it is. So if the sign is positive, it's a positive, it's negative, it's negative. The vertex form gives us information about the graph without drawing it. So same idea with the a value in standard form as in vertex form. If a is positive, or if it's greater than 0, then it has a minimum value at k. And if a is less than 0, then k is the maximum value. And then the axis of symmetry is x equals h, since it's always x equals the x value of the vertex. So here's an example. Y equals 3 times x minus 4 squared minus 2. So we want to find the vertex, the axis of symmetry, and the maximum or minimum value. So vertex form, I'm just going to rewrite it here so we can compare it, x minus h squared plus k. So the h matches up with the 4. So since they're both minuses, so the opposite of a negative 4 would be a positive 4. So my vertex is going to be 4, comma, and then our k value is negative 2. So without doing any work, we could find the vertex. The axis of symmetry is always x equals the x value, so x equals 4. Our a value is 3, so since it's positive, we have a minimum since it opens up, and it's a minimum at the y value of the vertex, which is negative 2. You can convert from standard form to vertex form by completing the square. So if we want to find the vertex form of y equals x squared plus 2x plus 3, we're going to write this out. So I'm going to write the x squared and the 2x. That's my ax squared and my bx. I'm going to leave a space, and then I'm going to put plus 3. So this is different than solving using completing the square because there's no equal sign here. So technically, yes, there's an equal sign with the y, but we can't move things to the side that the y is on. So since I can't move that 3 to the other side, I'm just going to scoot the 3 down. So from here, I'm going to complete the square. So I'm going to take the 2, and I'm going to divide it by 2, and I get 1. I'm going to square it, and I get 1. Now here's the part that's different than solving. I'm going to put the 1 here, but because the 3 is still on the same side, I can't add 1, because what I really have done then is add 2 to the problem, and I'm trying to add 0. So what I want to do here is subtract 1. So when you have everything on one side, in order to balance the equation, 1 should be a plus, 1 should be a minus. So I'm going to kind of just blockade this off. So that part that's in parentheses, that's our perfect square trinomial. So what we're going to do now is rewrite that. So that's going to be x plus 1, because of that 1, squared. And then outside the parentheses, I have plus 2. So this is now vertex form. Now the other way you could do this, it's more work, but if you want to, you can find the vertex from standard form. So do x equals negative b over 2a. So it would be negative 2 over 2. So x equals negative 1. Then plug in negative 1 and solve it. And then you end up getting that y equals 2. So since the vertex is negative 1, 2, if you plug it in, so the a value is still 1. We can see that from the original problem. So we have nothing in front. And then you use the opposite. So since it's a negative 1, we would put a plus 1 squared. And then on the outside, we have a plus 2. So we can get the same equation both ways, but completing the square is going to be a little bit faster. All right, so let's look at this problem. So now we want to complete the square and change this quadratic into vertex form. And then we want to identify the vertex, the axis of symmetry, and the max or min value. Okay, so first thing we're going to do, rewrite this. So f of x equals, I'm going to keep x squared plus 4x together. I'm going to leave a space and put minus 6. So I'm going to just put this in parentheses so we know that inside parentheses is our perfect square trinomial. So I'm going to take the 4 divided by 2, I get 2. Square it, I get 4. So I'm going to add 4 here, and I'm going to subtract 4 here. So f of x equals x plus 2, because of that 2, squared, and on the outside we have minus 10. So our vertex is going to be the opposite of h, so negative 2, negative 10. The axis of symmetry is going to be x equals the x value, so negative 2. Since our a value is 1, we know this has a minimum, and it's a minimum at the y value, so it's a minimum at negative 10. Okay, so here's an example where a is not 1. So we're going to do the same kind of idea. So what we want to do is we want to take the GCF out. So the 2 we want to take out. We always want the x squared term to be a 1, have a 1 as the coefficient. So whatever that coefficient is, we want to take it out. But we only want to take it out of the first 2 terms. So we only want to take it out of those 2. So I'm going to take the 2 out. I'm going to have x squared plus 6x. I'm going to leave a space, and then I'm going to put plus 13. So even if the 13 was divisible by 2, you don't want to take out the 2 from the 13. And you don't want to take out the x, that's part of the GCF. You only want to take out the number. So you want to take out whatever the a value is, put it outside. So from here, we're going to complete the square on the 6. So I'm going to take the 6, I'm going to divide it by 2, I get 3. I'm going to square it, I get 9. So we're going to put 9 here. But because I have the 2 on the outside, what I really have there is an 18. So I physically put a 9, but the value is an 18. If I multiply the 2 back in, if I distribute it, I get 2x squared plus 12x plus 18. So since I put an 18 there, I have to subtract an 18 on the outside. So I'm just going to do 9 times 2. So that's how we got the 18. So when we go to write this, g of x equals, the 2 is on the outside, the perfect square trinomial is x plus 3 squared, and on the outside I have minus 5. So now the vertex is the opposite of h, so negative 3, negative 5. And as for the axis of symmetry, so the axis of symmetry is x equals negative 3. Okay, and this last one. So here, the x squared term is a negative. So we always want the x squared coefficient to be a positive 1. So we're going to take out the negative. But again, we're only going to take it out of the first 2. So I'm going to take out a negative. So that becomes positive x squared plus 2x. I'm going to leave a space plus 3. So I'm going to complete the square on the 2. 2 divided by 2 is 1. I'm going to square it, and I get 1. So I'm going to add 1 here. Because I have the negative on the outside, if I distribute it back in, I physically wrote a 1, but that really stands for a negative 1. So since that's a negative 1, I want the opposite on the outside. So I'm going to put a plus 1. And that's because of 1 times negative 1. So since I really have a negative 1 in the parentheses, I have to put a positive 1 on the outside. So now we have y equals, the negative stays on the outside. I have x plus 1 squared. And on the outside, I have plus 4. And then this one would have a maximum since my a value is negative.